Concrete, the most common building material in the construction industry. Indeed, after water, it's the second most widely used commodity in the world. With it, we build the most amazing and useful things. Buildings, bridges and roads, dams and harbors, you name it, and you'll find enormous quantities of concrete, from the foundations up to the sky. But the concrete itself also comes in a wide variety of forms that are becoming more and more sophisticated as we improve the quality and properties of the materials we use. Each load that leaves the plant may be quite different from the others. First of all, it's important to know that concrete and cement are not one and the same. Cement being one of the ingredients and concrete being the final product. When dry cement is mixed with water, it becomes the glue that holds all the sand together, then sets like a solid piece of rock that we call mortar. I remember my dad would just mix up sand, cement, and water, then filled in a crack or laid some brick, whatever. Not anymore. Cements, concretes, and mortars come in a variety of types and codes for any number of different and specific purposes.
Currently, world production of cement is 1.5 billion tons a year and rising as we supply an ever-increasing demand.
But there is one material used in the production of concrete that's now getting more and more attention: fly ash. Fly ash is a byproduct of burning coal to fire power generating facilities. This ash, when combined with a source of lime or calcium hydroxide, creates a binder that has performance properties similar to cement. The ancient Romans discovered the same phenomenon when Mount Vesuvius erupted 2,300 years ago and found the resulting volcanic ash to be an excellent ingredient in the lime-based mortars they mixed to build structures that still stand today. You could say we are rediscovering knowledge of the past. The important thing is, it works. Since coal is available worldwide and is burned in generating stations just like this one, we get a steady supply of fly ash, known also as one of several coal combustion products. These products, or CCPs, were for many years considered to be of little value, that needed to be disposed of, usually in a landfill. By recycling fly ash as a cementing material, fly ash increases the performance benefits of the concrete mix and at the same time reduces its environmental footprint. By replacing a portion of the cement used in the concrete mix, fly ash reduces the greenhouse gas emissions attributable to the application. The use of fly ash thereby reduces the impact that the cement industry and power utilities have on the environment in terms of GHG emissions produced in the manufacture of cement and landfill required for disposal of coal ash from industrial furnaces. At the same time, the construction industry gains an excellent engineering material of great value. As a component material of concrete, the value of fly ash rises considerably.
Any concrete made with fly ash makes better concrete, provided all the precautions are taken. So that's a must, that you must have good quality control, you must have a good source of fly ash, and you must maintain your quality control during construction.
Nowadays, research, testing, and quality control are extremely advanced. For example, we can determine the chemical makeup of a sample with X-ray analysis. And we can test, evaluate, even predict the performance of concrete under almost any conditions in ways that were just not possible a few years ago.
Nowadays, I think researchers are being far more aggressive and ambitious in trying to replace more and more of the Portland cement component of concrete with materials like fly ash and other industrial byproducts to produce concrete with a high level of recyclable materials and yet very high durability.
Today, there's a lot more to concrete than most people imagine. You can pour it as a slurry, almost in liquid form, to fill cavities. There are even mixes that allow you to dig up the concrete more easily when necessary for maintenance or access to utilities. You can roll it as you lay it, or you can build with it to last more than a lifetime. That's progress indeed. And there are other properties of fly ash that offer distinct advantages.
We feel very positively about the quality of the final finish coming out of the form for fly ash concrete. It tends to be harder, tends to have less cracks in it, tends to be less porous. It gives off less dust. For exposed concrete, that's important.
By greatly reducing the permeability, we not only reduce the invasion of undesirable elements into the concrete structure, we also prevent certain trace elements from leaking out of the structure into the surrounding environment. This is especially desirable in marine structures.
So you improve its environmental aspects, you improve its properties, strength-giving properties, you improve its durability properties, and you enhance the environmental aspects. You make it much more environmentally friendly. It's all a win-win situation.
There's a lot of satisfaction in knowing that we really can build a better and stronger world for tomorrow, and at the same time, reduce the impact we all have on the environment in which we live.
In keeping with standard construction practices, appropriate testing of mixed designs with region-specific materials is required to assure constructability and durability. Application, together with environmental conditions on site, determine the specific methodology for a particular job.